Good afternoon, girls. It is exactly 3 o'clock on the dot for me, and I have only received one query to do revision on, so I'm going to go with that. And the query is exercise 2, differentiation, on page 181 of your Mindborn Purple book. And the question was specifically to go over questions that have surds in them. So I'm going to focus on exercise 2, page 181, B, 3, 4, 7, and 12. All right, so let's start with 3. Right, question 3, and we're going to be treating m as a constant here because we are deriving with respect to x. All right, so any variable that's not in the x that you're not deriving, you always treat as a constant. Okay, until we get to implicit differentiation, which is a topic you'll do next year. But for now, that's the kind of process that we follow. Right, so the first thing we need to do is make sure that the expression is in a form to derive, which means we get rid of surd signs, we get rid of variables that are in denominators, we get rid of brackets, etc. Right, so the 2 root x, we're going to change that into exponential form, so it'll be 2x to the half. And the 1 over 2x, we're going to take the x to the right of the fraction, so it'll become x to the negative 1. Plus 2m to the 5. Now we are ready to derive. So we're going to multiply this exponent to the 2 and subtract 1 from the exponent. Same here, multiply the negative 1 to the negative 1/2, subtract 1 from the exponent. Okay, so 1/2 times 2 is 1, then we get x to the negative 1/2. Right, second term, minus 1 times minus 1/2 is positive 1/2, x to the negative 2. Right, and then plus 2m to the 5 is 0. Right, let's get it into positive exponents, so 1 over x to the 1/2 plus 1 over 2x squared. And if you want to, you can go further and make the x to the 1/2 back into root x plus 1 over 2x squared. All right, number 4 is a little bit tricky because you might not have noticed, but in the first expression, the root is over the 6 and the x, and in the second term, the root is only over the 6. So that does change things somewhat. All right, so let's have a look. Okay, so one surd law that I want you to remember is that root 6x can be written as root 6 times root x. Okay, so we do this so that we can remove the variable away from the coefficient. And then obviously that root x can be shown as x to the power of 1/2. Okay, so that's what we're going to do in this question. So the derivative with respect to x of root 6x, we can show that as root 6 x to the 1/2. Remember, we haven't derived yet. We're just writing it in a form that we can derive. Okay, the plus root 6x is already fine to be derived, and the root 5 obviously is a constant. Right, next step, 1/2 times root 6 will be 1/2 root 6, and then subtract 1 from the exponent, we get negative 1/2, plus root 6, because the exponent here is 1, multiply to the root 6, and then subtract 1 from the exponent, we get x to the 0, which is 1. And then the derivative of the root 5 is 0. Right, let's tidy up. Okay, so the x to the negative 1/2 is a negative exponent, which we obviously want to get rid of. So in this case, we're going to be left with the root 6 at the top of the fraction, and at the bottom, 2x to the 1/2, which is also 2 root x. Okay, plus our root 6, and that'll be the final answer. There's no need to combine that into one fraction, getting an LCD and wasting time. Right, number 7, there are 2 things that we're going to do here. Firstly, it's not possible to simplify in the numerator because we've got unlike terms, and because there's only one term in the denominator, we can split this fraction, and at the same time convert those surds into exponential form. Right, so we'll have dx, then x to the 2/3 at the top minus x to the 1/2 over x to the 1/2. Right, now we can split those up. So x to the 2/3 will be over x to the half minus x to the half over x to the half. Right, now, it's quite simple in this situation because we've got a fraction which actually cancels out here and becomes 1. Right, so let's have a look. We're looking at using our exponent laws here. So for the first fraction, we have like bases, so we're going to subtract. We're going to say 2/3 minus a half. Right, and that gives us x to the power of 1 over 6 minus 1, and we can now derive. Right, so a sixth, the exponent times the coefficient gives us 1 over 6 x, and then 1 over 6 minus 1 is minus 5/6, and obviously the derivative of the negative 1 is 0. Okay, so let's put this into positive fractions, so we're going to end up with 1 over 6x to the 5 over 6. No need to put that into surd form. Right, number 12, whole lot going on here. We've got surds, we've got fractions with variables in the denominators, we've got brackets that have to be squared. So you can either get an LCD first, or and then foil it out, or you can foil it first and then get the LCD. All right, so it's totally up to you. All right, so let's start. Right, so I'm going to do this one by foiling first, okay? And that's because I can see already that it's actually going to cancel quite nicely. Right, so the first term, remember we still have our dx notation, will be root x over 2 times root x over 2, which is x over 4, which is a quarter x. If you need clarity on how I did that, there it is. Now the inners and the outers together are 2. And if you need clarity on how I did that, then there it is. That's the outers. And then obviously the inners is also 1, so the combination of them both is 2. And then the last term, 2 over root x times 2 over root x, is 4 over x, or 4x to the negative 1. Okay, we're now ready to derive. So for the first term in the expression, the quarter x, the exponent is 1, so 1 times a quarter is a quarter. Subtract 1 from the exponent, we get x to the 0, which is 1. Right, the derivative of 2 is 0. Any constant's derivative is 0. And then for the last term in the expression, negative 1 times 4 is negative 4. Subtract 1 from the exponent, we get negative 2. And then let's leave our answers with positive exponents, so it's going to be minus 4 over x squared.